Last week, JWST reported one of the most exciting discoveries from its first year of science. A nearly naked black hole that formed just 480 million years after the Big Bang. The black hole is around 50 million times heavier than our Sun and seems to have almost no host galaxy at all. It's so early in the universe that it should not exist according to the current leading model for how galaxies form. And that means that this discovery could force astronomers to completely rethink that model. In the past, we have talked about the incredible power of black holes and how they can influence the entire evolution of a galaxy by controlling the movements of stars within it. But even though we know that black holes play a crucial role in the life cycle of galaxies, we still don't fully understand their formation. We also do understand how they came to be so big so quickly in the early days of the universe. And this is where the newly discovered black hole, which the team has dubbed QSO1, could help fill in some major gaps in our knowledge. The reason scientists were so excited about this discovery is that the black hole is extremely young. It formed just 480 million years after the Big Bang, when the universe was only 900 million years old. At this point in time, the universe had already cooled enough for the first stars to form, and the light from those stars created the cosmic microwave background radiation that we can still see today. But the thing is, based on the current leading model of how galaxies form, there should not have been a giant black hole like QSO1 out there at this time. This model, known as the Galaxy First model, suggests that all large structures in the universe formed bottom-up, meaning smaller things came together to make bigger things. In the case of black holes, this would mean that they started out small and then grew over billions of years to become the supermassive black holes that we see in the centers of galaxies today. But if that's true, then there should have been a lot more time for the giant black hole at the center of QSO1 to form. Instead, astronomers think that QSO1 either formed at roughly the same time as its host galaxy, or even before it. If that is the case, then this would suggest that black holes may not need galaxies to form and grow, which would turn our understanding of their development on its head. This idea isn't too far-fetched either. Astronomers have seen a few other extremely fast-growing black holes at similar distances. But QSO1 appears to be tightly bound to its host, which makes it unlikely that it was ever a part of a different galaxy. It's also way too big to have formed through any kind of regular accretion. See, normally a black hole's mass grows gradually over billions of years as it pulls in surrounding gas and dust. But QSO1 grew by several million times in less than a billion years, which is way faster than any black hole has ever been observed to grow. So how did it get so big so quickly? Well, one possibility is that the black hole was born with an incredibly large mass, perhaps 100,000 times heavier than our Sun. Such a massive black hole could then have grown to QSO1's current size in just a few hundred million years. But the exact mechanism that would lead to such a thing is still unknown. Another possibility is that QSO1's host galaxy was much larger than expected at this point in the universe's history. Its giant size could have allowed the galaxy to cool more quickly and produce a huge population of stars that were able to feed the black hole and cause it to grow rapidly. Unfortunately, figuring out exactly how something like this could happen is going to be easier said than done. While JWST can observe the light that passes through QSO1's host galaxy, it cannot see what is actually inside of it. So for now, astronomers are left with more questions than answers. Next year, JWST will be joined by NASA's Nancy Grace Roman Space Telescope, which will have the ability to look deep into space and find even more massive black holes that formed in the early universe. By studying these ancient black holes, Roman will hopefully shed light on how the supermassive black holes that power the majority of galaxies today came to be.